What is up, guys? Today I'm going to be attempting to make a Bukkit tutorial on advanced or complex particle effects. I'm calling it advanced or complex because a lot of the tutorial I've seen online are really terrible. They don't teach you how to make cool particle effects. It's just really spawning one particle above a player's head or something very similar or simple like that. So I'm going to be teaching you how to create cool things like how to create a helix out of particle effects or different types of beams and stuff like that. So let's get started here. I'm going to create a event. So this particle effect is going to be triggered when there's a player interact event. And we're going to get the player who does this, call them player. And we're going to do, let's make it if they left click the air. So we'll have a condition if event.getAction. Oops. Event.getAction is equal to action.leftClick error. Then we're going to have a Bukkit runnable. So I'll do new Bukkit runnable. It's going to be .run task timer. The name of your plugin, mine is event handle. I don't know why, but that's what it is. .get instance. And then this parameter here is the delay before it starts, and the last parameter is the number of ticks between each loop it executes. So we're going to do 1 tick. And since we're updating every 20th of a second, it's going to create a much smoother animation. So in here we're going to create, in here we're going to have location. So this is going to be the location of the player. We'll call loc equals player.getLocation. We're going to have a variable t, which is going to represent the time, and that's going to start off at 0. And then we're going to have our runnable here. So public void run. And we're going to, every time this runs through, we're going to increment the value of t by Math.pi over, let's do 8. Where Math.pi is a constant pi, which is 3.14159 something. And now in here, this is the important math part. So here we have our parametric equation of the particle effect that we want to create. So for a helix, the parametric equation is x equals r times cosine of t, where r is the radius. So we'll create, we'll let our radius be, let's just make it 1 for now. And double y equals double y is just t, and double z equals r times sine of t. So basically, this is a parametric equation of a helix, and the parametric equation of a circle would be r equals r cos t z equals r sine t, and that would create a circle in the xz plane or the horizontal plane. The part with y equals t here, the reason why we have this is that over time the value of y is going to increase, so it's basically going to stretch out that circle and create a helix looking particle animation. After this we're going to do location.add those new coordinates, and then we're going to use protocol lib, or the effect library, to create the particle. So that is particle effect dot the particle effect we want to use. So there's a whole bunch of them in this library. I'm going to use flame dot display displayed at the location. So this is a player's location plus the position of the parametric equation. So that's where we want to display the individual particle, and these are going to be, these parameters are going to be 0, 0, 0, 0, and 1. These are basically, I think these are like the allowable offset from the given location or something like that. And this last parameter is the number of particles we're spawning, which is just going to be 1. And this is going to loop through a bunch of times because we have it in a runnable. It's going to loop through with different values of t, and that's how it creates that function. So what we want to do now is location.subtract, and we do this so that every time we loop through, it's not kind of exponentially getting larger. It's going to add the new function, then take it away after it displays the particle effect, because then the next time it runs through, these values will be increased or changed depending on their parametric equations. So we need to remember to put that in there, and I think that's about it. Oh, one more thing, so that this doesn't run forever, we want to add a conditional statement here. So we're going to check if t, which is time, becomes greater than math.pi times 4. We want to do this dot cancel. So if t becomes greater than 4 pi, we want to end this loop. We want to end the runnable. This needs to be final player. Oh. Alright, there we go, yeah. I'm genius at Java, if you didn't realize. Okay, so if that's fixed, let's export this, see if it works, what it looks like. Hopefully it does. Reload it. We're going to left click the air, and it creates a nice helix particle effect. So one more time, and there you can see it makes a cool helix. So if we want to change it, change the period of the helix, change the radius, we could, let's make the radius 2. We can make it increase vertically slower so that it'll be kind of compressed in a way, if you want to think about it like that. So we'll multiply that by 0.5, and we can also change, make it create more kind of loops, make that 8, and we could also decrease the amount of, decrease how much time t is increased by, if that makes any sense, each time it loops through, so that there's more particles per curve in the helix, so it's more, it has a better shape. Although it will be a bit laggier, but that's alright. So there we go, it has a larger radius, and it's kind of compressed vertically, and there's also more particles being displayed. So that's pretty cool. You can also change the effect you want to use, so we can make this, say, drip water, if you want to do that. We could change other things like say we want to change our parametric equation to something different, we can make this sine of t so now we have a new parametric equation, so it shouldn't be making helix anymore. I think it's going to make I think it makes some sort of circle tilted to the side, maybe. Yeah, so it makes a circle with radius 2 tilted on an angle, if you can see that. Looks kind of neat. I like the helix a lot more though. There, it's in the ground a bit. But that's all good. So, thanks for watching. Hopefully you enjoyed. This wasn't extremely complex. It was actually pretty simple. I just wanted to start off with the basics, and then maybe in another tutorial I'll do some cooler stuff, such as spawning in multiple particles at a time in different locations, so you can make like parametric surfaces instead of just single equations. You could have full surfaces, like making spheres and other cool shapes. So thanks for watching. Hopefully you enjoyed. If you did and learned something, leave a like. If you hated it and I was shitty, then leave a dislike. See you next time.